In this video, I want to take a look at modeling with series. So the good news for this video is we're not introducing anything new here that you need to be learning. All we're looking at now is using an arithmetic sequence and series and also a geometric sequence and series to model real life situations. So we're going to run through two questions here, one question based around an arithmetic sequence and the other question based around a geometric sequence. Okay, so let's get started here with question one. So question one here is looking at a arithmetic sequence. So what I've been told then is on his first birthday, Danny was given £30 as a gift by his brother. Now for every subsequent birthday, Danny receives £20 more than the previous year as a gift from his brother, and the amount of these gifts forms an arithmetic sequence. Okay, so for example, in the first year, here, that's when we have A, and that is £30. Okay, so that's £30. Then for the second year, well, this would be A plus my common difference here, D. So I've got A plus D. And in this case, then, he gets £20 more now than the previous year. So in this case, then, if you got £30 in the first year, in the second year, then he must get 30 plus 20. So he must get £50. Okay. And you can see the pattern that's clearly going to form here then in my third year. That would be A plus 2D. And then in that case here, I'm going to get £70. Okay. So that's the basis of this question here. Okay. So this here then forms an arithmetic sequence because it increases by £20 each year. So for the first question then, part A, it says, find the amount Danny received on his 7th birthday. So for his 7th birthday, then that would be the 7th term here. That would be U7. Okay, so we need U7. So we need U7. So now we're going to use the formula then for the nth term. So we're going to use UN. This is my formula here for the nth term. And that is equal to A plus n minus 1 D. Okay, so for this question, if we just think about this for a moment, in this case then, A is £30, that's my first term in the sequence. So A is 30. D, my common difference. In other words, what does it increase by or decrease by each year? Well, in this case, it increases by £20 each year, so that would be 20. So D equals 20. And then in this case here, N would be equal to 7. So we've got everything that we need here then. So in that case, U7, that would be equal then to A, which is 30, plus n minus 1 times D. So that's going to be 7 minus 1, so that's 6. So we've got 6 times 20 here, because D is 20. So 6 times 20. And in that case then, 6 times 20 is 120, plus the 30 there, and that gives me 150. Okay. So on his 7th birthday, then he gets £150. So not a bad birthday gift, to be honest. So that's the solution to part A. So we take a look now at part B here. Okay, so for part B, it says find the total amount of these birthday gifts up to and including his 10th birthday. So now it's asking us to find a summation here. What we're looking for here then is S10. I need the sum of the first 10 terms. We need S10 here. So to do this here, we need the formula then for the sum of the first n terms. So for an arithmetic sequence, and in this case it would be an arithmetic series, because we're summing these terms, then the sum of the first n terms, I'm going to use here Sn, and that is equal then to n over 2 times 2a plus n minus 1d. Okay, n minus 1 times d there. So again, we've got everything that we need here. The only thing that will change now is n. In this case, n would be 10. So for S10 then, the sum of the first 10 terms, that's going to be 10 over 2. We then times that here by 2a. So a is 30. Okay, that's our first term there. So 2 times 30 is 60. And then we've got n minus 1 times d. So n is 10, so that's going to be 9 times 20 there. So plus 9 times 20. So now we simplify all this here. 10 over 2 is 5. what I've got is 5 lots. Well, 9 times 20 is 180, plus the 60 gives me 240. So I've got 5 lots of 240 here, so that would be 1,200 then, because we're talking about money. So 1,200 there. Okay. And there we have it. So that's the solution to part B. So like you can see, even though we're looking at modeling real life situations, rather than just being given a formula or some very basic numbers and working through them, there's a little bit more context to this, but like you can see, the actual calculations that we're doing are pretty straightforward. Okay, so that's the solution to part B. Now for part C, it does require a little bit more room here, so I'm going to clear the screen just so we can have a go at part C. So for part C now, what are we told here? So we're told that just after Danny's 10th birthday, the total amount of money that Danny had received from the gifts was £9,600. So for part C, then we want to show that n times n plus 2 is equal to 960. So this can be quite tricky at first if you've never really seen an example like this, because all you're given is this information here, and then you've got to show that part. Okay, and it can be quite tricky to kind of make that connection between this statement here and this equation. But let's try and work through this here. So what we're saying here is on Danny's 10th birthday, or just after Danny's 10th birthday, the sum of the money that Danny had received from the gifts here was 9,600. So what we're saying then is for part C is that Sn, the sum of the first n terms here, that is equal to 9,600. And we know the result here for the sum of the first n terms. So using, we're going to use here Sn equals, so that is n over 2. So n over 2 times 2a plus n minus 1d. Okay. In that case then, we don't know what n is. That's what we're looking to basically show here and then find the value of for part D. So n we can't substitute anything in for, but we do know what the value of a is here and the value of d. So we also know that Sn here is equal to 9,600. So what I'm going to do then is set this equal here to 9,600. So what I've got here then is 9,600 is equal to n over 2. Then I've got 2a here, so that's going to be 2 times 30, so that's 60. Plus n minus 1, we don't know what n is yet, so we can't do anything with that. But we do know what d is. So d is 20, increases by 20 each year. So n minus 1, 20. Okay, so we're going to times all of that here by 20. So if I start by expanding this out here, and let me put this here on the left-hand side. I just think that looks a little bit neater. I've got n over 2. I've got 60 here. So if I expand this out, I'm going to get 20n. So n times 20 is 20n. And then minus 1 times 20 is minus 20. So 60 minus the 20 there would give me 40. So I'm going to get 40. And I've got n times 20, so that's 20n. So I get 40 plus 20n here inside the bracket. Once we simplify that. And this here is all equal to 9,600. Okay. So it's up to you now how you deal with this here, whether you expand this out or you just times through by 2. Doesn't matter either way in terms of how you do that. If I here expand this out, I'm going to get 40n over 2, so that's 20n. So you get 20n there, and then 20n times n over 2, that would be 20n squared over 2. So that would be plus 10n squared there. Okay, so I'm going to get plus 10n squared there. And that is equal to 9,600. What I notice here then is I can now factor a 10n out. So if I factor 10n out here, I get 10n outside the bracket. Inside the bracket here, we're going to get 2. So 10n times 2 would give me 20n. And then 10n squared here, well, what do I have to times 10n by to get 10n squared? Well, that would simply be n. Okay, so I get plus n there. This is all equal to 9,600. And then finally, what I notice now is we're pretty close here to what we need. I need n times n plus 2 being equal to 960. I've got 10n times 2 plus n, but that's the same as n plus 2, being equal to 9,600. So I notice here then, if I divide through by 10 on both sides, I'm going to get n. This here, this bracket, is the same if I write 2 plus n and n plus 2. It doesn't matter which way. But seeing as that's what they've got here, I'll write n plus 2. And that is equal then to 9,600 divided by 10, giving me 960 there. Okay. And there we have it. So as required there for part C. As required. And there we have it. So that's the solution there to part C. And then finally for part D here, it says hence or otherwise find the value of n. So hopefully for the last part here, this is nice and straightforward. All we need to do now is solve this quadratic here to find the value of n. Now notice what I've got here is a quadratic. So when I want to basically solve this quadratic here, we'd expect two solutions for n. However, what we would expect then is I can only have one value of n, and obviously the way that the question is worded would indicate that. So we want to find the value of n, so it's singular. And obviously I can have a negative value here for n, okay, because we're talking about the number of years here. So it's the nth birthday, so obviously that can't be negative, okay? So when I want to solve this quadratic here, we're going to take the positive solution. So I've got n times n plus 2 is equal to 960. So if I start here by expanding the left-hand side, I'm going to get n squared plus 2n is equal to 960. And then if I subtract 960 off both sides here, this would now be equal to 0. So I get n squared plus 2n minus 960. And that is equal to 0. And basically all we want to do here then is solve this quadratic equation here then. So it's up to you how you do this, whether you use the quadratic formula, whether you try and factorize this, or whether you just use your calculator. Either way, any of those methods is absolutely fine here. And what you'll find is this does actually factorize here, believe it or not. So in this case here, I can factorize this then into a product of brackets. So I'm going to get n at the front of both of these brackets here. Like so. Now, if you put this into your calculator, what you'll find here is you get two solutions for n. I get that n is equal to minus 32 and n equals 30. So what that means then is my brackets would be the other way around. So I'm going to get n minus 30 and n plus 32 there. Because when I actually solve these now, I need n equals 30 and n equals minus 32. So therefore, like we said, n is equal to either 30 or minus 32. But in this case, we can have the negative solution, so we're not going to include that solution there. So n in this case is equal to 30. So in that case then, just after Danny's 30th birthday, the total amount of money that Danny had received from the gifts was £9,600. Okay, and there we have it. So that's the solution to part D, and that gives the solution there to question 1. So if we just take a look now at one more question here, where we're now looking at a geometric sequence and series. So for this question here, we have a small business that predict their annual profits will be £50,000 in 2023. The business forms a model and predicts their annual profits will increase by 8% each year, forming a geometric sequence. So for the first part here, part A, we want to show that the predicted profit in the year 2025 is this number here, so £58,320. So for part A then, let's just consider here how this sequence is working. So in year 1 of trading here, so let me just do this underneath. So year 1, so that's the year here, 2023. Our first year of profit here, that's £50,000. So we call that term here A. That's our first term. Obviously, we know the value of that, but I'm just going to label it here as A. So we have A then for year 1. Now for year 2, so for year 2 here, that would be 2024. Now here for year 2, this is our previous term, so that's A, and we multiply that by our common ratio R. So we're going to get AR here for year 2. And you can see then what's going to keep happening here. So for year 3, do one more. So for year 3, that is 2025. we have AR times by R again, giving us AR squared. Okay. So we can either follow this pattern here, or we can just use the formula then for the nth term. So if we use the formula for the nth term, so that's is equal to AR to the power of n minus 1. Okay. So A, we already know the value of that. So A here is equal to 50,000. And R, now just be very careful with R here. So it increases by 8% each year. So be very careful that you don't put R equals 8 here. That isn't the same thing. So if it increases by 8% each year, the decimal equivalent of that would be 1.08. So 1.08 there. Okay, that accounts there for the 8% increase there. Okay, so that forms a geometric sequence. So in that case then, what we're looking for here is U3. So this is n equals 1, n equals 2, and n equals 3. Okay, so in that case then, U3, this is for the year 2025, which is what we're looking to show here, that predicted profit. That's going to be equal then to A, which is 50,000, times by R, which is 1.08. And that is to the power then of n minus 1, where n here equals 3. So 3 minus 1, so that's 1.08 squared. So all you need to do here is just put this into your calculator. And if you do that correctly, what you should find then is you get this number here. So I get 58,320. So 58,320 there. Okay, as required. Okay, so that's part A done there. Now for part B, we have this information that's given here. So the model predicts that year N will be the first year in which the annual profit will exceed £150,000. So if you think about this here, I've got 50,000, and then got my next year of trading and that profit there. Okay, so let's just say that's 54,000. Obviously, it's just A times by R. In fact, let me just work it out here, just so I can be consistent. So going on my calculator here, so I've got 50,000. I times that by 1.08. And yeah, I get 54,000 there. So that was a good guess. And then in my next year, I get 58,320. So what we're looking for here is the first year in which this profit is 150,000, or I should say exceeding £150,000. Okay. So what I require here then for part B is we need UN, our nth term here, to be greater, to exceed £150,000. Okay, this is what we're looking to find here. Now we know the formula for the nth term, that's AR to the power of n minus 1. So in that case then, we need AR to the n minus 1 to be greater than 150,000. And we do know the values here of A and R. So A is 50,000 and R is 1.08. So we should be able to show this here then for part B. So what we're looking to show then is we get n minus 1 times log of 1.08, and that's greater than log 3. Okay. So these logs here, we don't write, but this is base 10. Not that it really matters, but just in case you are wondering. So in that case then, using A equals 50,000 and R equals 1.08. Let's see if we can get this form here then. So that's 50,000 times R, where R is 1.08 to the power of n minus 1. And this must be greater here than 150,000. Okay. Now, the first thing that I can do here is divide both sides by 50,000. So 150,000 divided by 50,000, that would give me 3. So then I get 1.08 to the power of n minus 1. And this is greater here than 3. So like you can see, we're getting towards this point here. Okay, obviously, at some point, we need to take logs. And we're going to do that now for the next step here. So I'm going to take logs of both sides. Okay, so taking logs of both sides here, and then using the power rule to bring this n minus 1 down in front. So in that case, then I get n minus 1 log 1.08 And that must be greater than log 3. Okay. So all we've done here is took logs of both sides, use the power rule to bring n minus 1 down in front, and we get exactly what we need here for part B, so as required. Perfect. And then finally for part C here, it says hence or otherwise find the value of n. So all we need to do here then is find the value of m. If I just split these two parts here off, okay, so I've got part A up here, part B down here in the left corner, or bottom left corner, and then finally if I do part C over here, we want to find the value of n. So now we're going to go from this line here. So even if you can't do this here, if you can't show this inequality, you can still attempt and answer part C. So now we have n minus 1 log 1.08, and that is greater than log 3. Okay. So the first thing that I'm going to do here then is divide both sides by log 1.08. Now, in doing this, you need to be very, very careful that your logarithm here isn't negative. So if I just put into my calculator log 1.08, then you'll find it's a very, very small number, but it isn't negative. Okay, so it's greater than 0. And the reason that we need to check this here is because if this log here, log of 1.08 is negative, then that would flip my inequality here. Okay, so we just need to be slightly careful for that. Like I said, in this case here, this is positive, but it won't affect the direction here of our inequality. I'm going to get n minus 1, and that is greater than log 3. So I get log 3 over log 1.08, like so. And then finally what I'm going to do here is add 1 to both sides. So therefore, n is greater than log 3 all over log 1.08. Okay, and now we add the 1 here, so plus 1, like so. Now, what you're going to do is put this into your calculator, and what you should get then, so let me just quickly do it. So log 3 divided by log 1.08, and then add 1, and if I round that to 1 decimal place, what I get here is 15.3. Okay, so n must be greater than approximately 15.3. Okay, now we need to be careful here. So we're given the value of m. Now I can't say that n is equal to 15.3 because we're talking about a year here. Okay, so in that case then, what we have to do here is round up to the next integer value. Okay, so be very careful. We don't round down. We always round up to the next integer value. So in that case then, so what we're saying here is n must be greater than 15.3 if we round it to 1 decimal place. However, we need an integer value. In that case then, n is equal to 16. Okay, so that would be year 16. That would be the first year in which the annual profit will exceed £150,000. Okay, and there we have it. So like you can see, there's a lot more words involved, a lot more sentences and a lot more context, but the actual maths, the actual working isn't anything too challenging. It's just breaking it down step by step. Okay, so hopefully you found this video helpful. That is the solution there to the very last question, question 2, and that brings the end of this video on modeling with series.